Now let's look at an example problem of Johnson's rule. Remember, Johnson's rule is for two machine, and this is called flow sharp. Flow sharp means all the jobs flow through the same sequence of workstations, and this one minimizes what is called makespan. Okay. Makespan is the completion time of the last job. In other words, how long does it take to complete all the jobs that are to be completed? So we have a rework operation for damaged circuit boards, has two operations that all jobs follow. Okay. And here is the jobs are listed. So first you have to go to operation 1. Once that is completed, then you have to go to operation 2. So what we're going to do now is to first, step 1 is to determine the sequence. So you have first job, 2, 3, 4 and 5. So this is the sequence, right? Now here is the rule that the PowerPoint slide described, which I did not go over at that time. I'm going to go over it now. So the way to sequence the jobs is to look at all the processing times. Forget whether it is for operation 1 or for operation 2. Without regard to that, okay, just look at all of the jobs and select the one that is the smallest value. Okay, smallest happens to be 8. So you're going to now select E based on the fact that E has the smallest processing time among both the operations and all the jobs. So having selected E, now is the time to see which operation that selected number, the 8, belongs to. If the 8 belongs to the first operation, you would schedule the selected job the earliest possible slot. If it is for the second operation, you would schedule it to the last possible slot. So here this 8 happens to be for the second operation, so you will do schedule E there. Suppose if this had been reversed, if 8 was for the first operation and 12 was for the second operation, then E would have gone to the first slot. Okay, so now E is done, so we'll cross that one out. Now let's look at the remaining operation. Once again, don't pay any attention to which operation. Select the smallest value. Now this time the smallest value is 10. So you select B. Now consider which operation now. The 10 belongs to operation 1. So schedule B as earliest as possible. So that will be there. So now you cross out B. Now we repeat. So from the remaining operations, the one that is smallest is 24. Okay. Now 24, so you select A. Now should you schedule it the earliest or the latest? So that's going to depend upon whether the 24 is for operation 1, which it is. So the earliest, if it was for operation 2, A would have gone over there. So now A is done, and from the remaining, that one is the smallest, 25. So select C, and that is for the second operation. So you schedule it over there. So now C is done, so all that remains is D. So this is our schedule. The first job is B, and then comes A, and then D, and then C, and then E. So now we need to figure out the makespan. So we have to set up a scale for x-axis, which is time. Remember, this is time. And you need to be generous. Don't skimp, and if you're not generous, your Gantt chart will get all squished up and you can't read anything. So it requires a little bit of trial and error. So we'll start with operation 1. So this is operation number 1. It's a good idea to use a ruler. So we'll schedule operation 1 in its entirety first, and then we will look at operation 2. First one is B. So B takes 10 days or 10 hours or whatever the case may be. So that is 10. So that one is B. And then once B is done, A can begin, and A takes 24. So it will end at 34. So 34 is I'm going to be a little bit approximate here, which doesn't matter. So this is 34. So that's 10 and 34. So that's A. After A is done, next is D. D requires 30. So begin at 34 plus 30 is 64. So 64 approximately here. So that's 64 is D. And then C needs 32, so that will take us to 96. So 96 is C. And finally E is 12, so 96, 8108. The first operation will finish by 108.